Today's topic, Unit 1, Chapter 1, Unit and Measurement of Class 11th. Topic, Dimensions of Physical Quantities. So dimensions of a physical quantity are the powers or exponent to which the base quantities are raised to represent that quantity. For an example, the dimension of length is capital L, written in square bracket. Dimension of mass is capital M with a bracket, square bracket. Time is T. L and T, these are fundamental quantities. For an example, force. Force is product of mass into acceleration. So mass, acceleration is length per unit time. So mass is capital M, length is capital L, and time is T raised to minus 2. So ml T raised to minus 2 written in bracket. Second topic is dimensional formulae and dimensional equation. So the expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula of the given physical quantity. For example, volume, written in a square bracket, m raised to 0, L cube, T raised to 0. Speed or velocity, m raised to 0, L raised to 1, T raised to minus 1. Density, rho, m raised to 1, L raised to 3, T raised to 0. Next topic is dimensional equation. An equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of that physical quantity. For example, volume. So volume equal to m raised to 0, L cube, T raised to 0. This equal to symbol divides this mathematical expression into two parts, LHS and RHS. No equation can be called as equation unless there is an equal to sign. For example, force. Force ml T raised to minus 2. Density ml raised to cube T raised to 0. Dimensional analysis and its applications. According to the board pattern of ISC or CBSE, there is a 4 application of dimensional analysis and its applications. So here, dimensional analysis means when we are getting an equations, dimensional equations of mathematical expression with LHS and RHS, we need to check. So let's understand checking the dimensional consistency of an equations. So let us consider equations. So here an equation is there x, which is an x equal to x naught plus v naught t plus half at square. Students, LHS x and LHS equal to RHS. Here x is a position vector. So x dimension is capital L. So similarly RHS is x naught is also L, and v naught t is v naught is the initial velocity, L T raised to minus t and T raised to 1 equal to L. Half at square, half is a mathematical constant, neglecting it. So acceleration into time square, acceleration equal to L T raised to minus 2 and T raised to 2. So a raised to t square and minus t minus 2 cancel each other, become L. So capital L, LHS equal to L, RHS is also equal to L. So it is a dimensionally correct equations. So note, a dimensionally correct equation need not be actually an exact correct equation, but a dimensionally wrong, incorrect or inconsistent equation must be wrong. So second example, if you take half m into v square equal to m into g into h, this is based on the interconversion of energy. Kinetic energy is converted into potential energy. So here kinetic energy, we are replacing the mathematical constant. So we are giving mass into m is the mass, v is the velocity square. So m L square by T raised to minus 2, whereas m is the mass, g is the acceleration due to gravity, L square T raised to minus 2. Hence the LHS and RHS both are equal. Next topic, next